Hey YouTube, it's Dimitri, and today we're going to cover data types inside of R. So I know this video is going to be long. I'm going to try to be quick and to the point, but for those that are beginning programming, one of the biggest issues you'll run into is that you have the wrong data type. So maybe you're doing some calculation or you're using some function and it generates an error and you can't figure out why because it all makes sense in your head. A lot of times something's not the correct data type and so it actually won't work in the function you're doing. But let's just dive on in. Okay, so just to start off with, we are in our studio, so we're going to hit Control L to clear the screen, and then we're going to hit File, New, our script. So we're going to save our work up here. And today we are learning about data types and structures. So to start off with, R doesn't have scalars, which a lot of other languages do have. So an example of this is if we have x is going to be equal to 7, which we can copy and paste down below. This is just one value. This is considered a scalar in many languages. In R, this is actually a vector. It's just a one element vector. And we can actually create a vector that we're used to seeing here. And we're going to create this vector A. And we're going to use the same values from our other videos, 1, 2, 3, 4, and 5. And then we want to scale the vector of A by 7. So we're going to create a new vector called B, and we're just going to do A times X here. We'll copy and paste this. And we'll just hit B to print it out, and you can see now that our vector A has been scaled by 7. But technically, we need to remember that these are not scalars, these are vectors. So it's important to note inside of R that mode is the term for a data type. The mode function itself will actually call the type of data that we're looking for. So in our example here, if we wanted to do, we could type in mode, and I should note mode is lowercase. Okay, so we can type in mode, and we can do the mode of B, for example, which we know is a vector, and it's numeric. So that's what it's telling us. It's a numeric mode. Everything thus far we've done has been numeric. So far, we've seen numeric, but another common type is character. Okay, so we're going to create something called names. So a lot of times in data you have names, you might have country names, people names, you're going to have some type of character format here, and we can do the C here to concatenate all these, and instead of putting in numbers, we're going to put in a bunch of names. So Tom, Susan, Sally, and Robert. And again, this gives us a bunch of names. We can see these by typing in names, and it will give us Tom, Susan, Sally, and Robert. You can also see them up here in the global environment. And now we want to know what is the mode of names. Okay, so we're trying to figure out what type of data we're working with. If we type that in, it tells us this vector is going to be character. So something important to know here is if we mix numeric and character, we get character. So this is one of the biggest trip ups I see for a lot of people here. But let's create a list here. So we'll call it cats, and we'll create this called tabby, calico, American shorthair, and 7, 5, and 12. They're just random numbers here. So now we run this and it creates, again up here, our cats. And it tells us it's character right here, but we want to actually verify this. So we can type in mode and type in cats. And when you look at this, you can see that cats is character. So this is important because one thing I'm going to notify you here is that sometimes in R, you might have a vector that has all numbers in it, but for some reason it was classified as character. So maybe you have something like cats, and I go in and I delete out tabby, calico, and American Shorthair, and it keeps the character form. When you go to run this 7, 5, and 12 through some type of calculation, so let's try this real quick. All right, so if we take our character vector here and we try to do some calculation on it, so something simple, we're just going to take cats, multiply that by our vector x, and we run this, we're going to get an error. Okay, it says, cats times x, it's non-numeric argument to binary operator. What this is telling you is some of the parts of this vector are going to be numeric, and since the vector itself is character, meaning it has some characters in it, or it's classified as character, we cannot calculate math functions on character forms. The mode character is our type of mode here, but we also call multiple characters strings. Okay, this is common in computer science across the board, and so we're going to call this a string as its multiple characters. And so one thing we would like to do a lot of times is we would like to add together or split up strings. And so we can concatenate, get it? Cat? But really, we're just concatenating. We're going to add together here, we're going to concatenate the names. And so to do this, we're going to create our cat's first name, and his first name will be Tom. And then we're going to have our cat's last name, and it's going to be Smith. Okay, so let's just run these real quick. And you can see up here we have Tom and we have Smith. And again, you could do mode if you wanted to. So up here it doesn't tell you that their character is string or whatever. You could do cat first, cat last. It'll tell you its character. But up here it doesn't tell you its character. I don't know why, but I'm just proving to you it is character. And then the way that we end up putting these together here is we're going to use the paste function. So we're going to take our cat's name, which is what we want, and we're going to paste cat first name and cat last name. Okay, and this should give us Tom Smith, which is our cat's name. So let's paste it down here. And we get, cat name. Let's just type it in, let it print it out. His name is Tom Smith. But something else to note here, okay, right? Tom Smith has a space in it, and we might not always want that. So the default for paste is to have a space, okay? But a lot of times we don't want that. We want to add things together. Let's just say we want Tom Smith as one name. We can do that here, so we can do no spacing, so no space. And you can do the exact same thing. We can do cat name, and you can do paste, cat last, and then you put SEP equals, which is separation, and by default it has this with one space. Here, if you just put double quotes with nothing between them and hit enter, we can see down here, if we run it, that Tom Smith now is one name. But it's also common to want something else between them besides a space or no space. So a lot of times we might want a dash. So if you want a dash, we're going to do the same thing. So cat name, we're going to overwrite this again. Paste, cat first, cat last. Separation here is going to be equal to, do the double quotes, and just put a dash between it. And you could put any character between this if you wanted to. It's up to you. You could do like a // backslash, @ sign, or whatever else you want. And when you run this, right, we're going to do cat name, and it says Tom-Smith. Okay. So if you wanted to keep all these different cat names, you could name them different things, but you should note that I'm using the same thing, which is cat name. And since I overwrite it, so I'm assigning a different set of code to the same value here, which is cat name. It updates it, and then these old ones no longer exist. Okay, so now let's say, you know, I want to split the name. We can do this. We're going to call this cat split. And you put in str, which is string split, which is the name of the function we're going to use here. And then you put in what you want to split. So I want to split in cat name. And then you do a comma, and I tell it what I want to split by. So I want to split by dash, because in our scenario here, right, the last name that we have here, so cat name is going to be Tom-Smith. And if we put underneath of it cat split, so we're going to view what we printed. We copy this, paste this below, and it's going to give us Tom Smith. So now you'll notice in the top left here, we have what we call a list. Okay, so up here, we go to data, it says data now, and it says cat split, and it says a list of 1. So we want to know what a list is. So far we've looked at vectors. There's character vectors and numeric vectors. They can range from size of 1 all the way up to, you know, as large as you want them. But again, there's no scalars. And now we're going to move on to what we call lists. So instead of vectors now, we have lists. And so just to define this for you, a list is a group of different data types. And a list can hold a variety of things. But one example is that a list can hold character vectors and numeric vectors. Okay, so in our example here, my list, we're going to type in list, which is telling us we want to create a list of some sorts. But in this case, I want to put in A, which we created earlier. I would like to put in B, which is something else that we created earlier over here. And I also want to put in my cats, okay? And we want to see what type of mode my list is going to be. Okay, so we're going to copy and paste my list here. Okay, and we print it out here, and it tells you the mode is going to be list. If you type in my list, so you want to actually view it, it'll show you have 3 lists. Here's A, which is 1, 2, 3, 4, 5, right here. 7, 14, 21, 28, and 35, which was B. And then the third part of our list here is going to be, you know, tabby, calico, American shorthair, and all that. And if you scroll down here, that comes from our cats vector, which was numeric and character, but it makes it a character vector. So now let's say that I want to pull something from this list. So I want to reference something inside of this. We do this by using double square brackets here. So you need 2 sets of square brackets. And to do this, let's see if we can pull B, which as you can see in our list here, it's the second piece. So we're going to do my list. And I want to pull from this list the second component here. And if you copy and paste this below, it'll print out B, which was my list. Again, you could assign it to something if you wanted to pull B and relabel it something else. But that's how you pull things within a list. So a lot of times we're not going to know what number different things are inside of lists. And so doing it like this above, where you just put a list and put things in it, it's a pretty bad idea. So in reality here, we need to assign a name to each part of the list. And to do this, we're going to do something similar, which is going to be my list 2. And again, we're going to type in list with parentheses. And now we're going to label these. So A is going to be our cat's age in human years. B is going to be cat years, which equals B. And then 3 is going to be cat info, and we're going to set that equal to cats. And let's print out my list 2 so you can see what we're looking at. You can copy this, paste it. Okay, so now it's going to tell you this is my list, which we created, my list 2. You can see it up here now. It's with the other list that we've been kind of looking at. It also, when you print it, it tells you, you know, age, cat years and cat info, and it gives you all the information that you would want. So now what we can do is we can call parts of the list by name. So this is much handier and in practice. So let's say we have my list 2 and I want to pull out of there cat years. So to do this, we would do my list 2. And instead of the square brackets now, we can use a $sign, and it gives you some options here. But you type in cat years, and it's going to return our B list, which we labeled cat years here. So you print that out. And again, it gives us B. So you see cat years with the $sign gets pulled from here. You also will notice when we printed out my list, it will give you the $sign and then tell you the name. So you could have typed in, $sign age, and it would print out 1, 2, 3, 4, 5. So why are lists helpful, and what are they really used for? Lists are just used to store a lot of information that's generated from different functions. So in the last video in episode 2, we created a function and it generated one value. But in statistics, for example, or other types of analytics, we might create some function that does a bunch of things. It creates tables and a bunch of tables, and it does some plotting and a bunch of different things. So what we want to look at is all these different parts, and we want to store them into one thing, which we will store them in is our list. The best example here of a list is going to be the histogram function that we did in the first video, so episode 1. We're going to use the Nile data set here. And to do this, let's just type in cool chart, which is what we're going to call it. And it's going to be the histogram of the Nile. So we'll copy this, paste it below. So all this is doing is taking the Nile data, making a histogram for it, and saving it as something called cool chart. You see on the right here, it generates the histogram that we saw in episode 1. And there's going to be a bunch of stuff inside of histogram because it actually is a list, but we don't really know that right now. So what we want to do is say, okay, we ran this function, and I need to know what parts are inside of the histogram function here. Or in our case, right, what's inside of the cool chart that we created here. And to do this, we're going to do str. So str, let's make a note here. str stands for structure. So this is going to give us the structure of some object. So we're going to do structure of cool chart. And we're going to run this. And let's see what we get. Okay, so now it prints out this information for us. So it's a list of 6, which is important to note. You could have also went up here to the top right window and seen that cool chart is a list, and it's of 6, so that helps us out as well. But from the output here, you'll see that there are different components. So the $signs, as before, indicate different things we can pull from the list. So we have a $sign in breaks, we have counts, we have density, we have mids, we have xname, and we have equidist, which is going to be the equal distance, part of the function that's going to be used. And so we can actually call these. So something else to note, which I didn't mention before, numeric is just a type of data, so it's numerical data. So int stands for integer, and you can see here all the numbers are going to be integers. It's still a type of number, it's still numeric, you can still do calculations on it. Down here though, it's going to define these as numeric, so these are going to be other numbers, but they have decimals. I'm not going to go into that in great detail right now, but there are other things called like doubles, and that's just another type of numeric value, but it defines how many decimal places are after the number here. But we're not going to get into that right now. So right now we're going to actually look at some of these. So let's just define these and call them. So we have cool chart, and in the cool chart one, we want to pull our counts. Okay. And you hit enter and it prints out 1, 0, 5, 20, 25, and so forth. You can actually see though these, which are the counts, actually align to the chart here on the right. So the first bar is 1, the second one has no bar, which is 0, and then it's 5, and then 20, 25, and so forth. So these are going to be the Y values that R is using inside of a plotting function to create the histogram. And one other thing to look at is this line at the bottom, okay? So the ATTR this is just going to be what we call an attribute. And the attribute is telling us in this part of the function here that we have something that's a character and it's called histogram, and histogram is actually called a class. So the next type of data is going to be called class. And classes are used by generic functions. The best example I have is when we use the summary function, which we haven't covered yet. But if you did summary, summary function is actually used for overviewing the fitting of a statistical model. There are different types of models which can result in different types of summary output. Depending on the type of model, summary will use different code specific to that model. So why this is important here is that they're all going to have the same class here, but the summary function is going to call different sets of code for different types of data, but all those different models, which are different and unique, are going to be summarized by one class. And so they're going to have the class of summary. And when we talk about histograms, histogram is just another sort of class. It's a way of grouping things and a way of calling things. I'll cover class in further videos down the road, but just know that class are like lists, but they're different because class can apply multiple things to kind of a unique setting. But we're going to move on from those for now, so don't get too hung up on classes. The next type we're going to cover is matrices, which is our another data type. And these matrices are going to be the exact same type of matrices that you're using in data science or just mathematics, for example, in high school. And how we create matrices is, we can combine rows or we can combine columns. Rows is not very common, but for some reason, if you want to do it, we're going to give an example here. Let's create a few vectors. We'll create GDP with 1200, 1300, and 1100. And let's create something else called income. And income, we'll just pretend is in thousands. So like say 45,000, 102,000, and 63,000. If you add spaces here, it doesn't really matter. It's just for readability if you add them. And so we're going to create these two vectors. Let's paste them in. You'll see they're down here, over here on the right. And if you wanted to combine these in rows, so we wanted to create a matrix, based on rows, what you can do is we'll create this and we'll call it row matrix. And we're going to use what we call R-bind. So row binding, we're binding together our rows. We can do GDP. You can put an income here. We'll paste this below and it creates it. And let's just print it out by typing in row matrix. And it will give you our matrix here. And it just shows you that there are 3 columns here. There are 2 rows. And the rows have names, so GDP and income. And if you want to have a prettier function or prettier output, you can go up here to the top right and say where it says row matrix, you can double click on that. It'll open a new tab and show you this table, which just looks nicer. It has GDP and income, and then it doesn't have the numbers on the columns, but we know that it's 1, 2, and 3. So more commonly, we do matrix, but the matrices that we're going to use here are going to be column-based matrices. So this is similar to what we would be doing, for example, in R or Python. A lot of times we just like to work with things in columns. It's just how data analytics and quantitative finance and basically most types of analytics work. You just use columns. So we're going to call this column matrix. And instead of R-bind for row bind, we're going to do C-bind for column bind. And then we're going to put in GDP and income just as before. And we're going to print this out so we can see the object we created. Okay, copy, paste. And so it created it up here called column matrix. You can see it down here though. So now instead of the variables being on the rows, now the variables are actually in the columns, and then the rows are denoted by 1, 2, and 3. So we can call parts of the matrix by the rows and columns. So to do this, we give an example. Let's do column matrix, which is what we've been working with. And I want to see the second row and the first column here. So if you look at the table, this is going to be our column matrix. The second row is here. So the 2 here represents the row. And then we want to pull the first column, which would be 1300. So let's just print this out and see. It's 1300. And again, it gives us the title telling us it's the GDP column. Okay, now let's do column matrix. But let's say I want to pull the entire first row. So you do 1 and then comma and then leave this blank. And this will give us our first row from our table right here. And again, it gives us the headers as well. Now let's say we want to pull the second column. So we need to do comma first and then the column number. So we can copy that, paste that. And now this will give us the second column here, but it doesn't give us the header anymore, which is okay. But it's 45, 102, and 63. And that gives us our second column. And then finally, you can also do subsetting of these by selecting multiple ranges of numbers. So for example, let's say we want to get the first 2 rows of our table. So I want rows 1 to 2. And then I'm going to just leave the columns blank because I like to pull all of the columns for this. And you copy and paste. And you can see here that we end up with the first 2 rows. And since I didn't give it a column number, it takes all of the columns. And one important thing I should note here is matrix or matrices can only have one type of mode. So they can either be numeric or character, but you can't be both, okay? And that leads us to doing what we like to call data frames. So data frames is going to be our new type of data. And in the real world, data frames are extremely helpful because, as you can see with matrices, matrices are great if you're only using numeric or you're only using character. But a lot of times we might have like country names, people names, and then we might have like their GDP, their income, I don't know, their probability of default, their days past due, for example. You might have all kinds of data on them. And so we want to have basically like a matrix, but we want a mix of data types. To do this, we're going to use data frames. So let's start off with creating our country list here. And let's say we have Canada, Italy, and let's say Brazil. And let's run this real quick so we have our country. And now we want to combine together both the countries, which is character, the GDP, and the income, which is both numeric. To do this, we're going to create our first data frame. We'll call this first data frame. And you do data.frame, and then we type in country. Remember, it's case sensitive, and since I capitalized country, it has to be capitalized. And then we want to do GDP, and we want to do income. We can copy that, paste that below. And up here, it creates our first data frame. It says 3 observations of 3 variables. So now it's calling them variables because we're using data frames. And as I'm going to put here in the notes, don't forget to use a period between data and frame. So this plagues me all the time. I will type in something like this, but I will forget to put this little period in, and then it errors out and it says basically it doesn't know what data frame is as a function. So just make sure you have that period when you type in data frame. And so now let's view data frame. We'll double click up here to view it, or you can type in view data frame. It shows this really pretty nice table here, right? It has country, GDP, and income. You can also just type it below, and it will give you a similar table here, but you just need to remember that the top part is the variable names, and then on the left it's going to give you the row numbers 1, 2, and 3, but you get the same kind of structure and the same visualization. So the way I like to view data frames is that the data frame, let's do this in the correct capitalization, that the data frame structure itself, or this function, is a way to convert data into a data frame structure, or kind of a data frame type. So above here, we took different vectors. So for example, the country vector has 3 countries in it. We took that vector and we added them all together inside of the data frame function, and it converts it into a data frame. However, we can also put a list inside of here instead of vectors. So now we're kind of nesting different types of data together and merging it into new types of data. And so we're going to merge all this into a data frame. So let's do this. So let's input a list into a data frame. And to do this, we'll just call this ECON List. And we'll create a list, which we talked about earlier, which is a different type of data. And we'll put in country is equal to country, GDP equals GDP, income equals income, and then we'll copy and paste this below, and we'll do econ list just to see it here. So it gives you your country, which is going to be Canada, Italy, Brazil, your GDP, and your income. If you do not put in the equal sign here and give it the name, so the left part's the name you're giving it, it will produce a really ugly table, and you won't have column names or kind of column headers when we get to the data frame section. It'll be a really long list, and I believe it says like everything all merged together. So it'll tell you like Canada, Italy, Brazil, 1200, 1300, 1100, 45, 102, and 63 as the header. So we don't want that. So make sure you put in here a name and an equals. And now that we have our list here, we can convert it to a data frame. So let's call this econ data frame. And we do data dot frame. And then we put in econ list. We copy this below. And then you can see up here, econ data frame is now 3 observations and 3 variables, just like our first data frame, which is different than our econ list, which is a list. And you can print it if you'd like and see it's the exact same. Okay, and then to wrap a lot of this up here, one of the kind of the key features, as I like to view it, in R is that you can do nesting of functions. So we've done simple things which are easy to read and a lot of times better practice for programming, especially for people that are new. We created vectors, and then we took those vectors and put them into a data frame, and then we can use the data frame as an object. You could put vectors into lists and then lists into data frames. And to do that, we'll kind of show you an example here. So we'll call this nesting econ, since we're nesting all of our economic data here. We type in data frame, which is going to be the outermost shell. That's what we want at the end. And we're going to put in a list here. And we're going to put in country equals, okay, and then C, which is going to be to create the vector. And then you type in everything you want inside of the vector. So we have Canada, Italy, and Brazil. Okay, and then we need to close this vector creation with the second parentheses, or the first parentheses here at the end. And then we're going to do comma, and next, inside of our list that I'm creating, I want to add in GDP. So in this case, we're going to say GDP equals, and then we're going to create the vector with C, and we're going to put in 1200, 1300, and 1100. And then we need that closing parentheses, which it'll automatically do inside of our studio, then comma. And then the final one is going to be income is equal to C, and then our income, which is 45, 102, and 63. Okay? And then it'll have, if you look over here, this parentheses closes the income part. This parentheses closes the list part, which matches with this one. And then finally, the last parentheses here closes the data frame. Okay, so it's a really long and convoluted line, but you can write things like this if you don't want to create multiple objects and you don't want to store them all. So we copy and paste this, and then it will create nested econ or nesting econ. Let's print it out. And you can see here it prints out the exact same table here as we created earlier. And then the final note here for this video is that not everything can be put into a data frame. So there are constraints and issues with doing this. And these are going to be some of the errors you run into. Let's just create something called broken data. And we're going to do data frame. And we're going to put in my list, which we created earlier. And we're going to run this. And we should get an error. It says error in the function, and it gives you a bunch of stuff. But at the end here, it says arguments imply different number of rows, 5 and 6. So if we go up to my list here, we double click it and open it. So you can see here in my list, we have double, which is a type of number. There's 5. The second part inside my list is also a number, which is a double, which is 5. And then finally we have character, which is 6. So because we do not have the correct number of rows, DataFrame can't just merge them together. It won't add just a missing value. It can't do it. And something else, if you want to try this, you can also do something like, I don't know, called test error. And something as complex as like a histogram, for example, you can't put it in a data frame. It's not going to work. There are parts that just won't go into a data frame because how the data is structured and the types of data. But you can put in data frame, and we can put cool chart, which was our histogram. And again, it'll tell you there's an error in the function, and it'll tell you you cannot coerce class histogram to a data frame. So in this case, we cannot make this class histogram into a data frame. And that just wraps up our video here. So I'm hoping you guys have the takeaway here. There's numeric and character that go inside of vectors, for example, that go inside of data frames, that go inside of lists and matrices. So those are our 4 types of data: is list, matrices, data frames, and vectors. Almost everything in R, like I mentioned before, is going to be in a vector. They can be numeric or character. And later down the road, we'll kind of differentiate between different types of integers. So we'll go into like doubles, for example. But anyways, I hope you enjoyed this video. Don't forget to like, share, and subscribe. And as always, until next time.